Okay, this is the video tutorial that is supporting chapter 4 of my textbook. The title of the book is Finite Element Analysis or Essential in 3D Experience Release 2021x. And we're going to be doing chapter 4, which the title is The Need for Mesh Conversion Study. First, let me tell you what the problem is. We have a plate which has a central hole in it, and this is being pulled on both sides by a certain amount, tiny amount here, 0.05 millimeter. This problem was solved in chapter 2 with solid element, and in chapter 3 I did the same thing where elastic plastic response of it was done with solid elements, and now we're going to use shell elements to solve the problem. Because of the symmetry, we only need to model 1/4 of this, as you can see. The material properties are standard values for steel, and the amount of pulling is 0.05 in millimeter. Now, the reason I do this thing is I want to show you how easy it is in 3D Experience to create several different meshes uh, or finite element models. And then when it comes to analysis, you decide on which one you want. Okay, now in the chapter, I've done four different meshes, but here I will do only two. For example, I will do the one which is, let's say, the one on the right side, 8.272, and the one on the left side, which is left bottom side, which is 4.136 inches. Okay. Now you can see that when I do this problem, there is going to be 4 finite element models created within the tree, and when it comes to running it, it asks you which one do you want to use. It is also possible to change the section properties, but I'm not doing that. I'll just do the mesh. Okay. All right. So let's go ahead and log into my 3D Experience account. You're already there. Okay. So I'm going to start with a part file. Although I really should have started in generative shape design because we're doing surface and part design, you can't do surfaces. So we're going to switch to generative shape design in a second. I could have started it down there, right there. Okay. We're trying to hook up to the server in Europe, so this takes maybe a minute or so. If your installation is local, which I doubt it, then this is going to be a lot faster. Local meaning you're set up at the university administration center. Okay. All right. Now, there's more information in the results that I get in this chapter in the book itself. It shows you that as you progressively refine uh, the domain using finer and finer meshes, of course the results are going to be dramatically improving. The other thing that you'll see in the book is that you don't have to kill a fly with a cannon. You don't have to make the elements small everywhere, but you have to concentrate on places where there is a high stress gradient. Okay. So, but in this particular problem, in this particular tutorial, I will just uniformly make the mesh small everywhere. Okay. This is coming up. Just bear with me for a second. Okay, good. So let's close these things. Okay. So I'm going to switch to the other application, which is generative shape design. Okay. So on a convenient plane, on that vertical plane, I will sketch that 1/4 of the, the, the plate. Okay. So here is my rectangle. I'm going to dimension it in a minute. And here is a circle. I'm going to put the circle right there. Okay. And then quick trim. There's the quick trim. I get rid of this. Quick trim. Get rid of this piece. Get rid of that piece. And that piece. And now we're going to start dimensioning. Okay, so this is going to be 75 millimeters. Let me undo this. Okay. So let me actually start with this this dimension. Let me start with this dimension. This is 50. This one is 50, I believe. Yep, 50. Okay. Let's give a dimension to this circle. This is 12. What is that? Is that radius 12.5 millimeter? Okay, the only thing is that the center, the way I did it, is not there. That's why it looks weird. I can actually move it, but it's better if I made a constraint between this point, control that line, and I make it coincident. There are different ways of doing it. It's up to you. Coincident, okay? And also this point, control that line. I'm going to make it coincident. Okay, very good. And now I can change this dimension to 75. 75, okay, and there is my geometry, so I exit. Okay, so we're going to fill this thing, FILL, so you go to surfaces in the surface tab right there, and there is a fill, FILL, you select it, and you select the sketch, and you say okay. So what it does, it puts a surface on this. Notice that there is no thickness here, it's just the surface in there. So as far as making the model is concerned, this is the only thing that I need. While we are at it, let's go and create our material too. So tool, material, let's do a create material. I'll call it chapter 4 or 2021x, or 2021x, 2021x. Say okay. Okay, now in the book, most of the stuff that I'm doing, all of them pretty much, is that, that was this, by the way. What I do is I apply this to the part. It creates a dummy shell there, and I can change it. So this time I'm going to do it a little bit differently. So notice that I can say right click and simulation. So you input the numbers, the material properties right here before you apply it. You can do it like this too. So structures, abacus multiphysics, mechanical, elastic, and for elastic constants, I'm going to put 200 gigapascal, which is 200 e to the 6 Pascal, and e to the 9 Pascal, and for Poisson ratio 0.3. Say OK. Okay, so this is created. Now I can say right click, apply, and I'm going to close this window, material database window, and I'm going to select one of these branches, top one, and then a check mark. So the material is applied and the data has already been inputted. Just about everywhere in the book where I do this, I apply it first and then I come here and double click on it and specify the numbers. See now, the numbers are going to be there. You can see that. These are the numbers that I put in. So that's a different way of doing it. Okay, so we are pretty much, as far as the model and material properties is concerned, this is done. So we now switch to the structural model creation. You click on it. Don't change the defaults. This is fine. Okay. So notice that a finite element model has been created here. Of course, there are no elements and there are no properties. Now, if I had solid elements. As soon as I did this, as soon as I went through this step, a default mesh would be created in that solid object. If you look at chapters 2 and 3, videos for chapters 2 and 3, you see that happen. But here, because I have shell elements, okay, it won't mesh it automatically for you. So what we need to do is go to meshing, okay. Now here is a shell element that I'm going to be using, surface triangle mesher. You click on it. Now, I'm suggesting in the book that you use the linear element. These are the linear elements. And the support, by the way, is that face that I created, is that fill that I created, FILL, okay? And I'm going to be using two meshes. The first one, I told you that I'll be doing just two of them. I'll be doing 8.272 and half of that, okay? So these are the two meshes essentially. So it's going to be 8.272 millimeter. I'm not going to fool around with the sag, we don't need it. And then that's pretty much it. Now, if I click on mesh here, it will show you the mesh over there. So you click on the mesh, there we are. It's a terrible mesh, you can see that. It's a linear element, and the circle is basically represented by two chords, okay? So we say okay. All right. So notice that the mesh has been created here, and we can change the size of it later on. But now as far as the property goes, so I have to go to see now setup, not setup. So as far as the property goes, let's see now. You have to go to let's go setup, and then yeah, you change this thing to model. See, you're in the setup, you change it to model, and that will take you to the new action bar here. You select the properties and right there, okay? So we're doing a shell section, you click on it, and the support is that surface again. That surface, you can do it like that. And the thickness of the shell is 20 millimeters. That's something that I forgot to mention in the PowerPoint. Okay, the thickness of the shell is 20 millimeters. Okay, might as well add it here. Thickness equal to 20 millimeters. Okay, so let's move on. I'm going to save this and move on and say okay. All right. So notice that I have enough information to be able to, after I apply the loads and restraints, to run this thing. But I don't want to do that. What I would like to do is to create another finite element model with the size and the properties. The size is half of this. Okay. So what we do here, we go to setup. If you look in the setup, the older versions of 3D Experience had an easier way of doing it. But here I go again to, remember, I'm in the model. This is the model, setup tab, and way down here, there's something that says duplicate FEM within. So you click on it and it says, okay, you already have one here. This is fine. You already have one model here. Now what I want to do is I want to duplicate and include, and it's going to ask you to put a prefix here. So I'm going to say second. Second is going to be the prefix to that name that I have there, second underscore, and we say OK. So notice what happened here. I have a second. This is my original thing that you see it there, and I have a second one that is created there. Now these are identical to the top one. Properties, I don't mind them to be identical, but the size of this is going to be different. The size of this element is going to be different. Now, first of all, what I'm going to do is I'm going to hide this, and there's several different ways of doing it. One way to hide is just to put the cursor there. You say right click, hide. You can do that if you want. Oops, I guess you do it like this. Oh no. Well, okay, I guess that doesn't work. This is fine. So, oh yeah, because I did two of these. This what you're seeing here is the second one. So I'm going to hide it. Okay, good. So I hit the first one. The elements were still showing up because the second one was also on the screen. Okay, now fine. That's one way of doing it. The other way is to right click and go through visualization management, and then you select the finite element model to be hidden or the shapes to be hidden, etc. So anyway, this did its job. So let me put this thing back on the screen right there. Now I'm going to double click. I'm going to double click on this surface triangle mesh. And instead of the original value, I'm going to take half of that. So that's going to be 4 point, let's see now, what was it? 4.136. 136. And we're going to say mesh. So this is the new mesh with the smaller size element. We say OK. All right. So we have two basically finite element models here, and then we have to decide what is it that we want to pick. Okay. Okay. So this one, if you look at it, looks like that. And let me hide this. And this other one look like so. And you can have in the book, I have 4 of these progressively getting smaller, but that's really not what we want to do here. So anyway, we are done here. So let's save everything first of all. All right. Now, by the way, to hide these, you can use, of course, the tree, but you can also do this mesh visualization. And you go, for example, you're going to say visualization management for the finite element model. You can say hide, so it's going to hide that. Okay, something useful. Now we're going to go to structural scenario creation. Go there. This is where you apply the restraints, loads, and you define the step, etc. It is a structural problem that we're doing. And notice that as soon as we do that, of course, the action bar changes, but you get 2 exclamation marks down here because one of them, it doesn't have, we'll see how it works. Okay, so we go to setup. Notice that, see, we created 2 finite element meshes models. However, we haven't told the software which one to use. So you click on this, you click on that finite element model, and it tells you that, oh, you've got 2 of them. Which one do you want to use? Incidentally, you can create these things even at the scenario level right there. I did it before I got into scenario, but you can create it here, more finite element models with the elements and things like that with this button. Okay, but I don't want that. So let me go to the first one, which was the Corsair mesh. I'm going to choose this, and I say OK. All right. Notice that immediately that red exclamation mark turns into a green check mark. Okay, so now we're going to go to procedure. It's a static problem that we are doing. As soon as I do this, notice that this changed to green also, static step. This is a linear problem, so we take everything the same. Incidentally, if you go to the advanced one, it says include geometric nonlinearity. We're trying to do is a linear problem, so I'm going to uncheck that, and I'm going to say OK. All right. How about doing the restraints? Okay. Now this is giving me a hard time trying to visualize these things. So I'm going to say mesh visualization. Where is that? Don't show me the mesh. Good. I'll keep this thing there. Okay. Now restraints. This edge is a edge of symmetry. You say fixed displacement. And if you look in the book, it has a table which allows you to figure this out. It's very easy. This is a plane of symmetry xz, okay? So there's nothing, things don't move in the y direction because it lies in the xz plane. Things don't move in the y direction. and the rotations are exactly the opposite, okay? And the support is that edge. Now, is this edge. Now, if I can't pick the edge because it looks like I'm picking this whole thing, I'm picking the entire boundary of that, that's because your sketch is blocking that. If you go to the sketch, remember I drew this, I used the sketch, drew this thing and then filled it, hide that, and now you can select the individual edges, okay? So I hit the sketch one because it will not let me pick these individually, so I select this. And incidentally, this XYZ is referring to that coordinate system, but to begin with, these are all lined up with this, so with the global one, so that's okay. All right, very good. Now we do one for this bottom edge. This bottom edge is also a plane of symmetry, so we do another fixed displacement, the bottom edge, and this is a plane of symmetry. This lies in the plane of symmetry XY. See that? XY, the XY plane. Therefore, it does not move in Z, and rotations are exactly the opposite. Whatever was free here in this translation is fixed there. And we say, okay. Now, if I run this problem, it can still move in the direction, in this direction, in the direction uh, X, okay? This can move in the direction X when you think about it. So what I'm going to do is another one. Any corner point. Now, I don't know in the book which one I've done. I've taken that corner point or this corner point. It really doesn't matter. I'll take this bottom one. I'm not sure which one I did in the book. So no translation in X. Basically, it prevents rigid body motion. Okay? Good. Now, as far as the loads go, you click on the load. It's this edge that is going to move to the left by 0.05 millimeter. So let's see now. There it is. Apply translation. That edge. Okay. In the direction, this is direction Y, right? This is direction Y. Look at your coordinate system, direction Y. So you have to change this thing to translation Y, and the value is minus 0.5 millimeters, okay? Good. Well, I think we are good here. So let's save everything. We are saving this. So let's go ahead to simulate. First, do a simulation check, model and scenario check. That's done. Then we do a simulation check. Choose all the defaults. Let it run. There is a warning message. I don't know what it is. It's always helpful to look at these before moving on. At least you have an idea. So this doesn't seem to be any problem because it's saying there is no load. However, there is a load, and that was my translation. Okay. Okay, good. And finally, simulate. I'm sure it's going to be okay. We'll see. Yeah, it's coming along. And incidentally, you can plot the intermediate stuff here. This does not involve any iteration, but if there was iteration, you can ask it to be printed here or plotted here. This is going to be a straight line because it's a linear problem, really. And any messages are going to be in the first tab, okay? So we say okay. Notice that it's a horrible mesh, as you can see. Remember, it was a very poor mesh. This is step one. That's why everything is 0. Let me move this thing here. Okay. All right, good. If you go to step 2, here is the von Mises stress, and you can look at the displacement. Obviously, the biggest displacement on the left. Okay. Now, a couple of things here. If you double click on this legend, if you double click on the legend, it'll give you some information about about uh, uh, the plot issue. So, for example, it said smooth color. See that? If I uncheck it, it turns into distinct uh, color change between some boundaries. But if you say smooth, it just gradually smooth out to a different color. Okay. But fine. So we basically did this problem. You can extract information that you want on one meter stress and displacement and things like that. Now, if you want to rerun this with the other model, which was actually finer, what we're going to do is, let me close these first of all. Now, we're going to go to our scenario. There's the scenario. See that? It's a scenario, right? See, this is the model, this is the mesh, and here's the scenario. You click on the scenario, it'll take you back there, okay? And if you look at setup, okay, again, we have access to this finite element model. So double click on it, wait until the dialog box shows up. Oh, there we are. So I don't want the first one, I want the second one. You select this, and unfortunately that check mark stays there until you say okay. Then it's going to basically move the check mark down here. Good. So now we can go to simulate. Close this. Simulate. I'm not going to bother checking these other initial checkings. It's a bad habit, but I'll do it. Okay. Remember how bad a mesh it was before? So we're going to wait till this thing runs, and we're going to look at the deformation and the mesh and everything. Is going to be much better results than the previous one. Okay. Of course, I'm using linear triangular element. It was better to use uh, quadratic triangular element, but in the book, because I want to make a table and compare all these together, I started with linear, and therefore it's staying in linear. I'm sure we're going to get the same warning message there, but that's okay. Almost done. Yes. I hope my connection to the server was not cut. No, it's running. It's running. Same warning message, I'm sure. Right. And this is done. Extracting results, done. There we are. And notice that, remember how bad that mesh was? It was just basically two straight lines here. At least here we have 1, 2, 3, 4, 5, 6 straight line. So this is the displacement. This is the displacement, and this one is von Mises stress, etc. So as I said in the book, I did 4 of these. I created 4 models here, ran them successfully, put it in a table, and you're going to see that, yeah, things improve quite a bit as you refine the mesh. However, uh, I also show you in the book how you do a local mesh refinement along that edge. You can check it out. But if you're going to do local mesh refinement, it should be in this area, not back there. Not back there, nothing fancy, nothing exotic is happening. But over here, there's a big change in stress, and you want a big change in stress gradient, and you have to refine it in this area. Okay? Good luck, folks. See you later.